So this is the macroeconomic forecasting project I had. Basically, um, as an introduction, the following is a study of macroeconomic data using machine learning for economic forecasting. Basically, the project aims to explore macroeconomic data and make use of machine learning for forecasting with ARIMA. Other models would be used to possibly make predictions. EDA will be applied as well. Why does it matter? Forecasting and data exploration could be useful in making policy changes or making additional policy changes if correlations aren't as strong as we initially thought. Oftentimes, policy changes make a significant impact on macroeconomic indicators. What are the research questions? What will inflation, GDP, unemployment rate, and the federal interest rate look like in the future? Can indicators predict the other? What are some correlations between economic indicators? And what are some trends that occur when looking at the data? What is the frequency of most of the data? Basically, the project aims to explore trends, look at where most of the data is concentrated, make forecasts using ARIMA, and perform models with variables that have strong correlations. So, basic rundown is I just took four CSV files. I combined them. I changed the columns and changed the data types. And once I changed the data types and the column names, they were ready to be used for data exploration. There's a very small file. I think it was like 200 rows in total, spanning from the 50s to now. So let's explore trends and key events using Plotly. A simple line graph is used to explore trends. Annotations were made to explore the effect recessions had on indicators. As you can see, GDP and unemployment were most affected by recessions. Sometimes the interest rate was affected and inflation remains stable. Let me change that real quick. I should say interest rates. And as you can see, there's three recessions that occurred in the that occurred after 1970, and sometimes the interest rate is very high in response to those recessions. But what almost always is the case is that GDP drops below zero, and unemployment rate goes above 10% or very close to 10% in a lot of these cases, and that's because a lot of outside economic forces can affect macroeconomic metrics. As you'll see in the later slides, you'll see some of the correlations that exist and some of the frequencies that exist within the data. So then you have box plot, and I use this to explore frequency. Interest rate had the highest range of numbers, and inflation had the least. Values typically range from 0 to 5, except for unemployment, which had values more concentrated between 5 and 10. And if we explore this in further, it makes sense that the federal interest rate has the highest range of values because it's the one that can be most manipulated. And it typically most manipulated to control the next one, which is inflation. And you'll see there's going to be a strong correlation between these two. Then you have GDP and unemployment rate. And GDP, as you'll see in when we forecast the data, it goes between usually 0 and looks like 3. And unemployment rate usually goes between 4 and 10, whereas most of the data is around 5. Typically, that's a sign of a healthy economy when you have it's a sign. One of the signs of a healthy economy when you have the unemployment rate not in the double digits, and that's typically not the case for the unemployment rate. So you see the different frequencies and ranges of the indicators. Now we have correlations. Not a lot of notable correlations, since inflation rate and interest rate have the highest correlation regression. So as correlation, regression analysis will be run. In reality, the Fed will increase interest rates when inflation is too high or low, so this makes sense. GDP and inflation correlation also occurs in nature, but this shows a relatively moderate one. And this is why we do data exploration, is because if you look at economic theory, they would say that the inflation and interest rate would have a very high correlation, and so would the GDP and inflation would also have a pretty high correlation. But as you see from the real world data, that's not necessarily the case. The correlation, I think it's called P coefficient, is not not that high, and it's very interesting to see that be be presented in the real world data. So for the modeling, I'm going to use Riemann modeling for time series forecasting, and then I'm going to use a correlation that we had before, the interest rate and inflation, and we're going to use that to use predictive models such as linear regression, random forest, and extra tree. And then you have GDP forecasts using Riemann. The model has a mean squared root error of 2.22, which is pretty low, and the forecast is realistic if no recessions occur. While the model is not taking into account those recessions, the forecast of the percent change going between 0 and 2.5 is a realistic one. This combined with a low MSE means that it's a decent model. The only thing you have to really keep in mind is if a recession has occurred, the GDP is going to go below 0, because that's by definition what a recession is. So it doesn't keep that into account. And I did forecast this over 30 years, and it's sort of the same trend. It's going to be between 0 and 2.5. If you look at the box plot earlier, that's where it sort of is. So it's not a bad model. It's just that recessions occur, and that might fluctuate, change how the forecast is run. So not a bad model. The federal interest rate using ERIMA, this means squared error is almost 8, and the model is somewhat unrealistic. In nature, a natural setting, the interest rate changes according to the economic landscape to induce or slow down borrowing. This model shows an increase of the federal interest rate over many years, and this is not economically feasible. Not, as you see here, there are huge dips and valleys here that occur with the federal interest rate, and that's because the government is trying to induce or slow down borrowing to control inflation, and that's why there was that inflation, the correlation we saw earlier. So this is not the gradual increase of the federal interest rate. It's not a realistic one, and this is not a forecast that I would use. And even worse, on one that's also not usable is this. This has an unemployment rate. This has a high mean squared error of 24. The model is also questionable. If continued past 10 years, the unemployment rate is in the negatives. This is impossible. The unemployment rate changes greatly to economic contracting and recession-like events. So as we looked at before with the trends, the unemployment rate changes due to the recessions. And you're not seeing that fluctuation here. You're seeing a gradual decrease. And if you were to forecast this even further, the unemployment rate would be below 0, which is impossible. So then I use the correlation between the interest rate and inflation. I use the interest rate as a predictor variable and inflation as a target variable. And the model had a R2 of 0.47, which is adequate, but not strong enough for the interest rate to predict the target variable for inflation, which might tell policymakers maybe just relying on interest rate alone may not be sufficient enough to change inflation. There are so many other economic policy changes you can do to change inflation, because as you see here with the regression analysis and the correlation, there's not a lot of there's not a strong connection. It's moderate. So conclusion. So let's put the conclusion in several categories. Trends. Basic exploratory analysis reveals that recessions occur. That recessions cause certain indicators to fluctuate in data going high or low as a result of outside economic forces. This is true if you look at the line graph. Frequency indicators show that most most data was concentrated between values 0 and 5, except for unemployment rate. Inflation had the shortest range, and interest rate had the highest range, just because it's easier to change. Only one correlation: inflation versus interest rate was above 0.5. In many economic situations, the interest rate is used to control inflation. It was also a predictor variable for regression analysis. And we had the modeling. The modeling, all besides the GDP, were unrealistic. The GDP is the only plausible scenario, and the only one I would use to make for policy changing. And even then, you have to take into account the recessions that occur when we looked at our graphs. With interest rate as a predictive variable, inflation as a target variable, the model's R2 score was too low to be considered good. Therefore, the interest rate did not necessarily predict inflation. So this is going to might tell a policymaker that maybe just adjusting the interest rate is not good enough to adequately control inflation. And that's my project. Thanks.